Hi, kids. I hope you're not feeling undue pressure. Oh boy. Ugh, okay. Yeah, I do hope you're not feeling undue pressure because we're going to talk about pressure. So, all right. So, a little bit of background, and then we're going to talk about pressure at a depth. So hopefully we'll go into depth about pressure. Goodness. Oh man. All right. So, remember, pressure is force over area. In terms of units, newtons per. So the units for pressure are newtons per meter squared, which is a Pascal. Okay. Remember, we talked about atmospheric pressure, which, if you look on your handy dandy formula sheet, okay, one atmospheric pressure is 10 to the fifth pascals. A lot of times we'll say 101 kilopascals, but that's fine. 10 to the if you want to say either one, but you got to keep that in mind. And then the other thing to keep in mind is that the reason we talk about pressure with fluids as opposed to force, that if I fill up a container with a liquid, okay, remember a fluid is something that fills up its container. A liquid is something that can't be compressed. Well, the reason we talk about, okay, pressure is that as opposed to force is it really pushes on all the different sides. Okay, so when we're talking about pressure, it's pushing outward all different directions. If you think about like a balloon, it pushes against all the different sides. So we talk about pressure as opposed to force, which really just points one way. Okay. So the other thing, another little background thing, is just that remember, fluids move from high to low pressure until they are in equilibrium. Okay. And this is pretty cool because this is really how wind works and most weather pattern works. If you've ever watched the weatherman, he talks about high and low pressure. So really, if there's areas of high pressure, low pressure, that typically the wind is going to blow. Well, not typically, it's always going to blow from where there's high pressure to low pressure. So if it's really windy, okay, depending on which way the wind is going, that might mean that there's a low pressure zone coming in. It might mean that there's a high pressure zone coming in. Okay, but wind is the fluid trying to reach the air, being the fluid, trying to reach equilibrium. Okay, but high and low pressure. All right, so with that in mind, let's talk about this. So let's pretend I have a U-shaped container, okay? And I have like a stopper right here. There's a stopper in the U-shaped container. So there's my U-shaped container. And I'm going to put some, I don't know, water or something, some type of liquid on this side. Okay, so it's going to fill up like this. Okay. Well, you guys know what's going to happen if I take that stopper. Okay. The fluid's going to move. Well, let's talk about why is it going to move. Well, if you think about, right here versus right here, okay, that this has a higher pressure. This is going to be a lower pressure. So the fluid's going to move this way. So if you take this thing away, actually, let's just do it this way since I got a pencil. Look, I took it away. Pretty cool, huh? If I take that thing away, now what's going to happen? So here's my stopper is out. But now what's going to happen is this fluid is going to move this way. Okay, and it's going to keep moving that way until it reaches equilibrium. Well, when is it going to reach equilibrium? Well, it's going to reach equilibrium when the fluid on both sides is exactly the same height. Okay, because if one side was a little bit higher than the other, well, then it's going to keep going, okay, until it does reach this equilibrium, which kind of gives us a hint, okay, as far as pressure at a depth, so that really it keeps going like this until this point and this point are at equilibrium, okay, until this point and this point are at equilibrium. If it wasn't at equilibrium, then the fluid would keep moving. So, if you were to imagine here, well, this point and this point, well, in this situation, this would be a lower pressure, this would be a higher pressure, so the fluid's going to go this way. Okay, and that's going to keep happening until it reaches equilibrium. So one of the big takeaways, okay, this idea that fluids move from high to low pressure until they're in equilibrium, is that at any given depth, okay, at any given depth, your pressure has to be the same. So like if I was to say, a point A and a point B here, well, my pressure has to be the same there as long as it's in the same fluid. So, yeah, in the same fluid, the pressure at a given depth must be the same. Okay. And hopefully this goes right along with what we set up here. Okay. That if it wasn't the same, so like let's say A was at a lower pressure than B, well then it's going to keep going this way. Okay. Well then that doesn't make sense. That's why it has to go to the same height. And in fact, it doesn't matter how big or small the ends are. Like I could have a teeny tiny little tube here. So let's say I added a really narrow tube right here. Well, the instant that I added that tube, hopefully you see that this, okay, would be at a higher pressure than right here. So the fluid's going to move up. So the fluid would actually move up here. And then this other fluid would move down just a smidge because, so that, and this would move down just a smidge in order to fill it in. Okay? But it doesn't matter. So like if you have, different shapes, different, area tubes, it has to end up like that. Okay? Hopefully we're doing so far so good. Hopefully that makes sense. The formula for pressure at a depth is this. Okay? And then we'll do a little bit of practice with it. Pressure at a depth is going to be, and I do want to point out to you, okay, on your formula sheet, okay, hopefully you have your formula sheet. If you look under fluids, density equals mass over volume, super important. Pressure equals force over area, super important. And then you have this formula, which is really pressure at a depth. Here's really what this formula is saying, is that the pressure at a depth equals whatever pressure is above, and I'll explain that in a minute, plus, okay, rho GH for the fluid that is above you. So it would be something like that. So hopefully that makes sense, but let's do a practice problem with that. Okay, at least a practice situation with it. Actually, I'm going to pause it, and then we'll do the practice situation in just a minute. Okay? Bye, kids!